My project is focused on different ways of dealing with uncertainty, particularly in geospatial visualization, so in maps and spatial data. I wanted to have a little bit on here of sort of what is uncertainty, what do I mean by this, because it's something that I guess it would be irony, is not particularly well defined always. If you get your guys' dictionary definition, it's the state of being uncertain. That's not particularly useful in any meaningful way. But I'm using it in the terms of essentially anything that renders a measurement less than perfectly accurate. And as we all have some data experience, we all know that nothing is absolutely accurate. It's just not possible to do that. So this could be measurement error, measurement bias, any missing components in there, or any sort of ambiguously defined concepts or different sort of the way you structured the questions that you're asking. To turn a little bit to things that are more related to maps and geospatial stuff. This can be the positional accuracy of the device you've used to record location, so GPS error, essentially. This can be the choice of the geometry you've made. Representing a river as a line does not capture the entirety of it. Representing, say, an archaeological site as a point does not represent the entirety of that archaeological site. It can't. So you're making a choice there, and you're putting some uncertainty into it. There's all sorts of error terms that might be associated with the model. If you've done some sort of interpolation, there's an error there. If you're dealing with something that comes from a satellite, there is an error that almost always gets completely ignored by any researcher looking at it. And then there's also sort of questions of different scales of measurement that we can have in there. And then the sort of fundamental issue of administrative differences. And I just have an example of what I mean here, because when you're dealing with things, particularly in a big data context, this is a map that I rudely did not put an acknowledgement in, but this made the rounds on Twitter, social media a few years ago. This is all of the rivers of the US. And if you zoom in on it, you begin to see pretty quickly that different administrative units, so counties essentially define rivers differently. So there are places where rivers just stop at the edges of counties. This happens all the time. Roads will just stop at the edge of a county, rivers, all sorts of other things. Geology is terrible if you try to go from one state to another. So having researchers understand this is pretty fundamental to creating good geospatial visualizations, to dealing with maps in sort of an instructional context. So there's a lot of different ways to represent these things. And the reason I'm mostly interested in this topic is, like a lot of universities, the University of Notre Dame, we don't have a geography department. So there's no natural home for learning how to make maps, how to do spatial visualizations. And it's something that the library has kind of taken up. So I teach the only GIS classes on campus, and I teach the only real workshops that focus on this sort of thing. This means that the students outside of these classes, they might go to YouTube to learn how to use it, how to use the software. They might go to just any old blog on the internet. They're not getting the training in sort of the understanding of the uncertainty that underlies the data that they're dealing with. So we want to make sure that they're getting this in some sort of useful way. So there's a lot of different ways we can represent these things spatially. For things like positional uncertainty, you could use the size or the color of the point, the location to represent it. That has some serious issues with it because it makes uncertain things look bigger and more obvious, which is kind of the opposite of what you want. So you have to do some sort of tweakiness on that. Tweakiness, yeah, that's the 4 hours of sleep talk. We can also do sort of fuzziness on borders or opacity, sort of used to represent an error term. I have an example up here. I'm not sure what the time is looking like. So I'm not gonna follow that link. But essentially, it's coloring a raster image so that the uncertainty term, the error term is how transparent it is, how opaque it is. And then there's all sorts of uncertainty in statistical measures as well. I can't tell you how many students I've had come in that have found some awesome data from the American Community Survey and they want to toss this right into their analysis, forgetting that there is an error on that. And that's a known error that only begins to understand what the actual error is. Census data, all these things, they systematically undercount lots of different types of populations. So how do we teach people this is important, especially in contexts where we don't have a natural home for this kind of instruction? I'm working on sort of incorporating these things into early GIS, early mapping workshops, guest lectures. I give tons of these in different classes throughout the year. It'd be really nice to have just a simple couple of slides that sort of talk this over to the students as they're beginning to learn these kinds of concepts. But beyond that, I want to develop a suite of tools for instructors or just independent learners to be able to find and learn how to effectively visualize or at least understand the uncertainty that's sort of intrinsic in their data. And then I'd like to post that somewhere with some techniques for doing this in ArcGIS, QGIS, R, most of the big mapping software.
Thank you.